So in this video, we'll be going over the solutions to practice exam 1. So this is going to be a pretty typical representation of what kind of graphing problem you could be given on the exam. So you may be given a position versus time graph like you have here, or a velocity versus time graph, and be asked a series of questions about it where you have to use the graph and describe what kind of motion is it depicting. So for this one, we have a position versus time graph. Basically, we're asked a series of questions where we need to list the time or the time interval where it fits that motion. So starting with problem 1, we have an object is moving to the right. So in the problem, we're told that to the right is the positive x direction, and then to the left is the negative x direction. So moving to the right would mean that we would need to be gaining position, so increasing in the positive x direction, and all of the time intervals here, we either have a horizontal line or we have a downwards pointing line. So that means that we're only either staying stationary or moving to the left. To move to the right, we would need to be going like up. So like I've drawn right here. So the answer to number 1 is none as a result. For 2, the object is speeding up. Well, what does that mean? So that means we need to determine what the velocity is. And then, to be speeding up, we would need to have the acceleration in the same direction as velocity. So to speed up, remember, A and V need to be in the same direction. So how do we get velocity from a position versus time graph? So let's recall that velocity is equal to the change in position over the change in time. And the change in position over the change in time is equal to the slope of a position versus time graph. Because remember, rise over run, change in y, change in position, over change in x, change in time. So the slope at any given point, that's a terrible drawing of that, but the slope here is going to look something like that. Slope here is going to look something like that, and like that, and then we're getting bigger and bigger. So the lines I've just drawn are the tangent lines to those points, which is going to tell you what the slope is at that point. And so that means that each of those lines is the velocity at each of those points. So what can we say about those velocities? Well, those velocities are pointing downwards. We have a negative slope at those points. So we know the velocity is in the negative x direction, or to the left. What do we know about acceleration? Recall, acceleration is equal to the change in velocity over the change in time. So is this velocity changing? Sure is. I mean, the steepness of those curves tell you the magnitude of that velocity. So if it's getting steeper, that means that the velocity is changing. It's getting an acceleration. So it's getting steeper in the direction that it's moving in. So that means the acceleration is negative. And that means we must be speeding up. You can also just tell that it's speeding up because the steepness of the curve tells you the magnitude of the velocity. So if we are getting increasing steepness all of the way, that means our velocity is getting bigger. It's getting more negative, but it's getting bigger in that direction, which means it must be speeding up. So between 0 and 0.5, we have a horizontal line. What does that tell us? A horizontal line, change in position would be 0, so the velocity would be 0. So from 0 to 0.5, this region right in here, the object's not speeding up. It's just staying constant. Only once we reach 0.5 and we move onward do we have a negative velocity, but a negative velocity that is increasing, getting more negative. So the entire time range from 0.5 seconds to 5 seconds is our window where it's speeding up. The object has 0 velocity. Well, we just talked about that. So that's on a position versus time graph. The object has 0 velocity when there is a horizontal line. So horizontal line. The object's acceleration is directed to the left. Well, we just talked about that. If the object's speeding up, that means acceleration and velocity are in the same direction. So since our velocity is negative, that means our acceleration must be negative. So for the time interval of it speeding up is going to be the same time interval for its acceleration. One thing to note, if you're given a position versus time graph that has a curve like this, that looks something like a parabola, then that means you're going to have an acceleration. So for curved position versus time graphs, there is an acceleration. So by curve, I mean something that looks like what we have here and not something like that. Because remember, the slope of a diagonal line is a constant, which would mean you have constant velocity, which would mean that you have no acceleration. So if you ever see a curved position versus time graph, curved, then you know you're going to have an acceleration as a result. Moving on. So these are multiple choice questions. You're not going to be given multiple choice on this particular exam, but for future exams, you could possibly see it show up. You've gotten practice with it in Expert TA within the homework and the quizzes. So the only types of multiple choice questions that I will ask are conceptual questions. You won't be solving any problems and having to choose from a series of numbers. That's not what multiple choice is best for, in my opinion. It's good for conceptual questions because it really tests your understanding, because we can choose answers that are common misconceptions to the answer. So they may seem right, but it's actually just testing a misconception. So that's why you've gotten practice with them through Expert TA to really gauge, do you understand the material or are you just kind of plugging in numbers? So again, just to reiterate, you won't see any multiple choice questions on this exam, but on future exams, you could be given them. So that's why I've included them, just to get practice. And these are testing the concepts that could be applied on this exam. So here we have a velocity versus time graph. Assume positive is to the right. So we have the question 5 asking the object is blank, moving to the right and slowing down, moving to the right and speeding up, moving to the left and slowing down, moving to the right and speeding up. So let's take a look at our curve. We know that we have a negative velocity. This is negative, this is positive. So we have a negative velocity. So what does that tell us? That tells us we are moving in the negative direction. So if, again, to the right is positive, that means to the left is negative. So we must be moving to the left. Now the other question is, are we speeding up or are we slowing down? So our curve is starting from, say, -5, and this is 0. We're starting from -5 and we're moving towards 0. So what's happening to the velocity? We're getting less negative, so that means we are slowing down. We're decreasing our velocity. So the answer is C. What about the acceleration? Well, if we're slowing down, what does that mean about the relationship between velocity and acceleration? So for slowing down, V and A must be opposite directions. So if our velocity is negative, that means our acceleration must be positive. And so that's answer A. Moving on to the next part. So for 8 for 12, we have a position versus time graph for two cars, A and B, driving along parallel lines. Which is going faster in the beginning? So we have a position versus time graph. To get velocity, we need to take the slope. So the slope at the start, which is here, which is here. Which one has a steeper slope? B has the steeper slope. For 9, during the time interval shown, A is blank. So again, we kind of alluded to this in the previous problem, 1 through 4. When we have a diagonal line on a position versus time graph, that tells us that the slope is constant. So that means the velocity is constant. So for A, which is this diagonal line, the slope is constant, so the velocity is constant. So it's C. For 10, during the time interval shown, B is what? So the position, we have this curved position. So again, what did I say back up at 1 through 4? If we have a curved position versus time graph, we know we have an acceleration. So if we have an acceleration, we must be either speeding up or slowing down. So for this, what's happening to the slope as we move up? So say at the start here and at the finish here, what is the comparison of the slope? At the start, we have a steeper slope, and then at the top, we have a much more horizontal slope. So that means that the velocity is starting out high, but the velocity is then plateauing until it reaches 0. So we're starting from a big number, and then we're going down to 0, so that means we must be slowing down. So for 11, during the time interval shown, which has the greater average velocity? Well, average velocity, again, is change in position over change in time. They both have the same change in time, since they're both going and stopping at the same t point. So we just need to figure out which one's traveling the furthest. Well, the initial position of B is right here, so that's x naught B, and then A is up here, x naught A, and then they're both ending at the same spot. So xFA is equal to xFB. So B has the greater change in position. So it must have the greater average velocity. So now for 12, we need to mark on the axis where they have the same instantaneous velocity. So the key here is they must have the same slope. So where is the point on B that has the same slope as A? So you just need to find the line that's tangent to a point on B that matches A. and they will have the same instantaneous velocity.